this video, we're going to wrap up the second derivative test, and in particular, we're going to show where it doesn't work, the cases where it doesn't work. So if you remember, we know that when the second derivative is positive and you have a critical point, you're going to get a relative min, right? And if you have the second derivative being negative and have a critical point, then that critical point is going to be a relative max. But we never discussed what happens when the second derivative is 0, when you're neither concave up nor concave down. Well, when just because your second derivative is 0 doesn't necessarily mean you're concave up or you're not concave up or concave down. That's the point that we're going to make here. So the question is, what happens when f double prime of the critical point is 0? And we're really just going to look at 3 examples. Alright? So let's look at example 1. Let's look at the function f of x equals x to the 4th. In the second, we'll look at, let's call it g of x equals negative x to the 4th. Whereas example 3 will be h of x equals x cubed. So let's see. Let's take derivatives here. So for f prime, we're going to get 4x cubed. And for f double prime, we're going to get 12x squared. Alright? This means that our critical point, which we'll get right here, alright, we want that to be 0, so that means x equals 0. That's our critical value. That's our CP, or critical point, sorry. But now observe that when you plug 0 into the second derivative, you actually get 0. So what's happening there? Well, let's draw the picture. Look at the graph of the function. Here's the x-axis, y-axis. We know x to the 4th looks like this. It's like a sharper version of x squared. It's a little narrower, narrower version of x squared. And look at here. The tangent line at x equals 0 has slope 0, because that's where the critical point is. But we can see the function is concave up. But the second derivative is 0. So it's not positive, but the function is still concave up. So the point is, the second derivative doesn't tell you exactly when the function is concave up or concave down. But if you know for sure if it's positive or negative, then you'll get to know something about the concavity for sure. But if it's 0, look, we still have something that's concave up. And of course, let's go now to g of x. Why am I putting negative x to the 4th? Because I'm going to make a similar point. Obviously, it has the same critical points as x to the 4th. The only difference is that the graph is like this. And so critical point is at x equals 0. The second derivative is still 0 there, but this time you have the graph of the function being concave down. And so g double prime of 0 is still 0. Alright? It didn't tell us that the function was going to be concave down. And finally, in the last example, x cubed, we know that that looks like this function. This looks like, the graph looks like this. And if you take the first derivative, well, obviously, we're going to get the critical point to be x equals 0 again, because it's this first derivative is just 3x squared. The second derivative is going to be 6x. And so we know x equals 0 is the critical point. That's a CP. And this is automatically going to tell us, just because of the way h double prime is, that h double prime at 0, well, that's just 0. So let's look at this. Here's the critical point. We know, well, it looks like the graph I drew is a little bit inaccurate here. It technically should be like this. Let's just redo this so that it looks a little bit more accurate. X cubed comes along like this, and then it gets flat just at x equals 0, then it goes up. Okay, and so why am I doing it like that? Because we know this is the critical point, so the slope of the tangent line has to be 0 there. Okay, so you see the critical point is at x equals 0, and at that point it's not concave up nor concave down. In fact, we have an inflection point here. The concavity changes exactly at that point. And the second derivative is still 0. So the second derivative isn't telling us, when the second derivative is 0, it doesn't tell us anything about concavity, and that's why we can't conclude anything about the critical points in those cases. So when the second derivative is 0, you can't tell what that critical point is going to be.